This is part 3 in the tutorial series. Go watch part 2 if you haven't already. We're going to be setting up a GitHub repository. And to start, you want to set autosave to true. You're going to want to click the link in the description. Then I'm on a Windows machine, so I'm going to press Windows. And I have an x64 CPU, so I'm going to click on that. And then I want to run the exe file and press install. Once Git's installed, you then want to go to the left-hand side of your screen, hit source control, and then click initialize repository. So then you're going to see all the files in the project with the use symbol next to them, which means they're untracked, which means they're not a part of the repository yet. So what you're going to want to do is you're going to stage all these files to be ready to be committed to the repository. I'm going to click this plus icon here that says stage all changes. Once all the files have been staged, you then want to commit them to the repository. You want to give it a commit message. So this is going to be the initial commit, and then you want to press this commit button. That'll commit that onto the main branch. Now to publish the branch, which is to actually get this on GitHub, you want to click publish branch, so allow, and then you want to log into your GitHub account. Open VS Code through your browser. Then click publish to a private repository. Then I can click the link to open the repository. And now I can see all my files are there. So if I go into src, bot config, which we're editing, all my stuff that I edited is there. And now if I want to make a change, so let's say I don't want a distance reset. It'll be changed. Stage the change. Then I can commit it. So we'll say moved distance reset. Commit it. Sync. Then now when we go to our GitHub repository, refresh, as you can see, the changes took place. So this is basically a backup of your code, and this way, for whatever reason in a competition, you lose access to your laptop, you can quickly download this code, download zip, and then boom. There's your project right there. And you can also rename the repository to make it more personalized. I'll name mine 654x robot code. That's just a very brief overview. If you want to learn about more what you can do with Git and GitHub, I'd recommend reading this article that I'll have linked in the description. Now I'm going to be going over how to set up the assembly class. The assembly class is going to be different for every robot, and this assembly class that I have set up is for my high stakes robot. What I have for my high stakes robot is I have 2 motors that lift this Lady Brown upwards at set positions. I have another motor for the intake, and then a solenoid which deploys a back clamp here. It's recommended that you have a basic knowledge of C++. For learning C++, I recommend learncpp.com. This is where I started. And you can just kind of briefly go through each chapter and click on what you want to know, help you understand the code that I'm going to be going through in the video, and so you can write your own code. To start editing, you're going to click on assembly.cpp, and then you're going to click include, click on assembly.h. So assembly.h is essentially declaring all the functions and variables that you want inside of your class, whereas the CPP file gives them functionality. So in my H file, I first declared the devices that I want in my assembly class. So I want a motor group with for the Lady Brown, and then I want a motor for the intake motor. Then I want a rotation sensor, which will give me the position of the lift arm, the Lady Brown. And then I also have a piston for the back clamp. So I have 2 custom classes that I'm using that are part of the MIC namespace. So you don't need to use MIC motors, you can just use the regular VEX motors. However, the reason why I prefer to use the MIC motors is because when you declare them, you give a name to the motor, and that makes it really convenient for displaying motor values on the UI, so that way there's a name for the motor. And then the reason why I use the custom piston class right here is because it has a little bit more features than just the regular digital out. So if I hit F12, I can go to the class, and as you can see, I can open the solenoid, close it, and then I can toggle it on and off, and then just the regular set, which you do with the digital out. And then the rest are just the stock VEX code template devices. So if I wanted to add an extra piston, go in the H file, I'd write MIC piston. Then on my high stakes robot, I have a sweeper or a doinker, whatever you want to call it. Name it sweeper piston. That. Then when I go to my robot config, just add that here. Add another piston. Then say it's on triport E. And there you go. That's setting up my assembly class. This is just a parameter though, and to create the actual object, so I can move the piston, I'd want to create it down here. Piston. Then that allows me to, I can go to main and access it. That. So then I want to head to assembly.cpp to start adding functionality. And so I want to complete the constructor to how it looks in the header file. Piston. Then I'm also now going to set the parameter to the actual object. So do it like this. This is text for it. One thing to note is this port B is just an integer, but to actually create through-wire devices, you need to pass in a triport, and I already pre-convert it when I'm creating a MIC piston. So if you're creating something that is 3-wire but isn't MIC piston, let's say I'm creating a limit switch, how I'd create it is I do 2 triport and then put the ports, like port C. And that's how I declare it. So back into assembly.cpp, we have 2 functions that are going to be called. One with the start user control, and then one that's going to be continuously called during user control. First one is init. This will just be called once. And what I'm using it for is to create a task, which will be moving the lift arm to a position continuously. So what a task is it will run at the same time as other sequences in the code. So this is going to be running at the same time as my regular control loop. In the control loop, this is where you want to put, if you click a button on your controller, it will perform an action. You want to put those functions in here. So I have the lift arm, intake motor, and then the long piston. So first I'm going to go over the intake motor control down here. So how it works is while I'm holding down the L1 button on my controller, it'll spin the motor, the intake motor forward at max speed, which is 12 volts. And then if I'm pressing L2, then it'll spin it in the reverse direction at 12 volts. So I use -12, or you could do reverse 12 like that. That would be valid syntax. And then if I'm not pressing any button, if I'm not pressing the L1 or L2 button, then I stop the intake motor. So now I'm going to go over long piston control. And how this works is I'm using a macro that is custom to this template called button A new press. And what that does is it converts controller.button.a.pressing into a toggle. So how it'll work is this will only become true, this if statement will be true, when controller button A is pressed for the first time, and it'll be false until controller button A is released and then pressed again. So this toggle only executes when I click button A, I have to release it and then press it again to click the button again. And the reason why you want to use the macro instead of just doing it like this is because when I hold down controller button A, it'll keep rapidly toggling long piston over and over again. And that'll make it so you can't toggle your pistons on or off properly, and it'll just waste air. And what some teams do is they'll add a sleep function. So instead of doing this, you do sleep like 300 milliseconds. But the issue with that is during the execution here, since control is going to be called like fast in a while loop, any sleep, it'll just be waiting on the sleep function. So it'll call lift arm control executes, intake motor executes, but then it'll call this, but then we have to wait 300 milliseconds before then going to lift arm control. And so that's why we want to be using this macro right here. The last control function is lift arm control. And how this works is I'm once again using the new press macro. And so when button X is pressed, I will set the lift arm position to scoring. But if it's already scoring, then I set it to loading. Then the same thing here, except if button up is being pressed, I'll set the position to loading. If it's not loading, then I'll set it to idle. And so what lift arm position does is I have another while true loop here that I set to be ran in the task over here. And that's using the lift arm encoder to check how far we are away from the desired position that we want to be. And then we use a PID loop to spin the motor to that correct position. So I'm going to be going over PID in the next video, so don't worry about that for now. And how I'm making it loading turn into an int is I'm using an enum up here and called lift positions, and I have idle set to 229, loading 226, and scoring 99. And those are angles from the rotation sensor. So to add support for the sweeper piston that we created earlier, we first want to go to assembly.h and create the control function. So we'll call it void sweeper piston control. And we already have our object there, so we're good. Then you can just copy this function, go to assembly.cpp, scroll down to the bottom, paste in the function, but then it's a part of the assembly class. So do assembly : sweeper, move the semicolon, brackets, and now we can do if button, we'll say B, press, controller dot button B dot pressing. Then we do sweeper piston dot toggle. And then to be able to use that in user control, you can put the function in. And now it'll call it in the control loop. So the last thing to go over before we can start running the user control is if you go to main.cpp, I have chassis.control and drive mode. And so this is how you're going to control the drivetrain with your joysticks. So I have it set to split arcade curved, and that's actually a feature from lemlib, and that allows, as when you're turning your robot, it creates smoother turns by curving the robot. If you don't want that, you can just run split arcade like that. Or if you want tank drive, which is where you use both joysticks to move the robot forward, then you can do drive mode : tank or tank curved, which does the same thing as split arcade curved. So I'm most familiar with split arcade, so I'll just set that to split arcade. And then we're going to be running the control loop. So when you start the program, you're going to see on the controller the Auton selector screen. And to get rid of that, so you can start driving the robot around, you can press X on the controller, or you can comment this line out here, comment that line out. Or if you just want to not run the UI altogether, you can comment this line out in pre-Auton. And here's what the control loop looks in action. That's it for part 3. Stay tuned for part 4, where I go over how to use the miclib UI and tune your PIDs through it.